Okay, so today we're going to cover balancing redox reactions. What I have written down here are the 7 steps for balancing a redox reaction in acidic solution. So, this is an overview of everything that we're going to cover. I'm going to switch to the next page and we will begin. Okay, so this is the overall reaction that we're going to be working with, and it's hypophosphorus acid plus dichromate yielding phosphoric acid and chromium ion. So the first step is to write out our half reactions. In order to write out our half reactions, we look at each reactant on the left side of the equation and what it turns into on the right side of the equation. So based off of that, our first half reaction will be H3PO2 turning into H3PO4, and our second half reaction will be Cr2O7 2- yielding Cr3+. So to do this, we took our H3PO4 and saw that it turned into H3PO4, and then our Cr2O7 on the left side turned into Cr3+ on the right. I'm going to redraw these half reactions on the next page. Okay, now that we have our two half reactions redrawn from the previous page, our next step is to balance all the elements except for H and O. So for this, we look at each half reaction separately. On the left half reaction, the one in red, we see that the only element besides H and O is our P. And we can see that we have one P on the left and one P on the right. So those are perfectly balanced. So our half reaction is going to stay the same after this step. For the left half reaction, on the right we see that the other element besides H and O is our chromium. And on the left side we have 2 chromiums, and on the right side we only have 1 chromium. So we need to make 2 chromiums on the right side, and to do that we will put a 2 out front. So our new half reaction will look like this. Okay, so now our new half reaction has a 2 out front, so we could see that there are 2 chromiums on the right and 2 chromiums on the left of this half reaction. So I'm going to redraw these 2 new half reactions on the next page. Okay, I've redrawn the 2 half reactions from the previous page, and our next step, step number 3, is going to be balancing the oxygen by adding water. So for this we can see the oxygen, we're going to look at our left half reaction and our right half reaction separately. In our left half reaction, the one in red, we can see that on the right side there are 4 oxygens, on the left side there are 2. So we need to add 2 more oxygens to the left side by adding 2 waters. So our new half reaction is going to look like this. Okay, now we can see that by adding the 2 waters, there are now 2 plus 2, 4 oxygens on the left, and there are still 4 oxygens on the right, so those are balanced. We're going to do the same thing to the right half reaction. In this one we can see that there are 7 oxygens on the left and none on the right, so we need to add 7 waters to the right side. Okay, now that I've added 7 waters, we can see that there are 7 oxygens over here, still 7 oxygens over here, so those are balanced. I'm going to rewrite these half reactions on the next page. Okay, now that I've redrawn the half reactions from the previous page, we're now going to balance the hydrogens by adding hydrogen ions. To do this, we have to look at the charge, not the charge, but the number of hydrogens on either side, just like we did for the oxygens and the other elements. So over here we have 4 plus 3 hydrogens, which gives us 7. And over here on the right side of the left half reaction we have 3. So we need to add 4 hydrogens to the right side to balance out our left half reaction. So I'm going to draw out the new half reaction. Okay, now that we've added 4H plus to the right side of the left half reaction, we can see that we have 7 on the left and 7 hydrogens on the right. So that's exactly what we want. Now we're going to do the same thing to the right half reaction. On the right we see that we have 14 hydrogens on the left because it's 7 times 2, and we have none on the right, so we need to add 14 hydrogens to the right. To the left. We need to add 14 hydrogens to the left side because we have 14 hydrogens on the right side of our right half reaction. I'm going to draw out the new half reaction. Okay, now that I've added 14 to the left side of this half reaction, we can see that there are 14 hydrogens on the left and 14 hydrogens on the right, so those are balanced. I'm going to redraw these new half reactions on the next page. Okay, I've redrawn the two half reactions. So now our next step is to balance the charge on either side, on each half reaction by adding electrons. So first we're just going to look at the left half reaction, the one in red. So if we look at this one, the charge on the left side is 0, and the charge on the right side is a +4 because of the 4 plus charges. So we need to add 4 electrons to the right side of this reaction in order to bring the right side overall charge to 0 to match the left side. So I'm going to draw out the new half reaction. Okay, so I've added 4 electrons over here to the right side. So now we can see that the charge on the left side is still 0 and the charge on the right is now 0 because we have a +4 charge plus a -4 charge because of the 4 electrons that I've added. I'm going to do the same thing to the right half reaction. On the right half reaction, we can see that the left side has an overall charge of +12. That's because there are 14 positives plus the 2 minus charge that's on the Cr2O7. So when we add those together, we get an overall +12 charge on the left side. On the right side, we can see that our overall charge is a +6 because of the +3 times the 2 out front. So in order to balance these, we want to get them both to +6. So we're going to add electrons to the left side to turn that +12 into a +6. Okay, so I've added 6 electrons over here on the left side so that the overall charge, when we add up all these charges on the left side, will equal +6 because we have a -6 plus a -2 plus 14, which should give us a +6. And then over here on the left side, we still have our same +6 charge. So now all the charges are balanced for each half reaction. I'm going to redraw the new half reactions on the next page. Okay, I've redrawn both of the half reactions. Our next step is to balance the electrons between the two half reactions, because eventually we want to recombine these two reactions. So in order to do that, we need the electrons on both sides, or on each half reaction, to be the same. Now the common denominator between these two would be 12. So I'm going to multiply the left half reaction by 3 and the right half reaction by 2 in order to get the electrons for both half reactions to be equal to 12. I'm going to redraw these two half reactions. Okay, so now we can see that there are 12 electrons on the left half reaction, 12 electrons on the right half reaction, and each coefficient has been multiplied by the number that we multiplied each half reaction by. So you can see each one. Okay, so now I'm going to redraw these two half reactions on the next page. Okay, so here are two half reactions. Okay, so here are two half reactions, and I've written the first half reaction on top of the other because now we're going to be combining and canceling them. So it kind of looks like an addition problem, right? So previously we made sure that the electrons on the left half reaction match the electrons on the right because now we can cancel them since they are on opposite sides of the arrows. Okay, so what else can we cancel? Well, we see that we have 12 H pluses on the right side of the arrow and we have 28 H pluses on the left side. So we can eliminate these 12 H pluses and that leaves us with 16 hydrogens on the left side. We also see that there's water on both sides, so we have 6 on the left and 14 on the right, so our 6 is going to be eliminated, and that leaves us with 8 waters on the right. Okay, so let's start writing out our new formula by combining these two. So we have 3H3PO4 on the left. What else do we have on the left? So that's it that's on the left of the top one, because we have to remember the arrows right there. So then we have this Cr2O7 on the bottom, so let's add that. Plus 2 Cr2O7, 2 minus. And we still have these 16H pluses. So 16H plus. Now we do our arrow because we've covered everything that's on the left side of the arrows. For the right side, we have this 3H3PO4 plus our 4Cr3 plus, and we still have these waters. Now we look over our two equations and see if there's anything else we can cancel, and it doesn't look like there is. Okay, so now we look at our two problems and we see that there's nothing else that can cancel. So we're done. This is a perfectly balanced redox reaction.